gang, let's take a look at 2K. So the first thing, if you do the golden rule and you plug in the 1, you get -3 over 1 minus 1 squared, or -3 over 0. So the first thing that should occur to you is that you're at a VA. Now, since you're at a VA and it's two-sided, there's 4 things that can happen. There's 4 things that can happen, okay? So you could be going opposite this way, or opposite this way around the VA, or you could be going together this way around the VA, or together this way around the VA, right? So if there's a VA, it could be going up, and it's two-sided, right? It could be going up on the left, down on the right, or vice versa, down on the left, up on the right, or they could both be going up, or they could both be going down. So when you're saying a two-sided limit, I can't, for instance, say that the answer is positive and negative infinity. You can't say it's 2 answers. You can't say it's positive and negative infinity. You can't say that. So for this scenario, the best I could say is DNE. Same here on this one. I can't say, well, it's going to positive and negative infinity. You can't give 2 answers on a limit. So for this one, I would also have to say DNE for two-sided. Now, for this one, on the left and on the right, they're both going to positive infinity. So I don't write DNE because positive infinity is better. I do not write DNE because positive infinity is better. They're both unbounded upward, okay? Same thing here. These are both unbounded downward. So I don't write DNE here because they're both giving me the same answer from either side. So I would write negative infinity for this. All right, so what's happening here in this one? The limit, as x goes to 1 from the left, if you pick something a little bit smaller than 1, something like 0.9, okay? You'll notice that the top is always going to be negative, and that it doesn't really matter what you pick here, really, because the top will always be negative because there's no variable. The numerator will always be negative. The denominator will always be positive because it's squared. So if I put in 0.9, you'll notice I have negative infinity. But it doesn't matter because this will always be positive. And then if I go to 1 from the right of this, so something like 1.1, you're going to have the same issue because the numerator has no variable here, so it's always negative. The denominator, you could put in 1.1 and then square it is positive, so this is negative infinity. So the limit doesn't exist for the left or the right side, but it specifically is going to negative infinity. And since it's going to the same infinity on both sides, therefore the two-sided limit is that infinity as well, okay? So it's going to be the case where they're both going down. All right, so it's a scenario where it's got a vertical asymptote at 1, a horizontal asymptote at 0, and then they're both going down from both sides of it. Okay, I didn't really leave enough room to draw that, but for those of you who remember this stuff from, and at 0, it's going to be, yeah, these are both going to be going down, so you're getting this. It's always going to be negative. Okay, gang. Now for this one, this is the rule that I just did in a previous video. You have degree 3 on the bottom, degree 3 on the top. I'm sorry, I'm so squished now. This is degree 3 in the numerator. It's degree 3 in the denominator, so it's degree 3 over degree 3. And remember the rules. This is the 4.6 because you're going to infinity. So remember, if it's top heavy or the degree of the numerator is higher, it's going to positive or negative infinity. If the degree of the denominator is higher, then it's going to 0. If it's equal in degree, then it's the ratio of the leading coefficients. If it's equal in degree, then it's the ratio of the leading coefficients. So this is the case where it's equal in degree. So that means that the answer to the limit is the ratio of the leading coefficients. Now, the ratio of the leading coefficients might be hiding if it's not in descending order. So sometimes you have to watch for that. But both these polynomials are in descending order. So it was the 3 over the 5. Okay, gang, that's it on this one. I'll catch you. Bye-bye.